Hi guys, today I thought we'd look at lenses. I've got a laser box which will show how the pathway of light changes as it passes through different lenses. The first lens that we'll look at is a convex lens. Now a convex lens is wider in the middle and thinner at the edges, so that's our convex lens. And we'll look at a concave lens, and as you can see this is the opposite. It's thinner in the middle and wider at the edges. The convex lens is often called a converging lens because light comes through it and converges to a focal point, sometimes also called the principal focus. On the other hand, this one is a diverging lens. Light comes through it and spreads out. Now the important thing to remember with both of these lenses is that they have a focal point each side. Because they're symmetrical, if light comes through from this direction, the focal point will be here somewhere. If it comes through from this direction, it will be here somewhere. The same with this one. So remember in the exam, when it says to draw the focal point can be this side or the other side because it's a symmetrical lens. Okay, so let's have a look at the experimental setup and see what we're actually talking about. So on the board, we can see that we've got 3 rays coming from the light box. If I place a convex lens here, we can see that we've got a focal point. So on this one, let's mark that focal point there. And let's mark where the lens is. Now, if we take another lens, a shallower lens, the same shape, so we're still talking about a convex lens. Let's put it here and line it up roughly where the other one is. We can see that the focal point's moved along a little bit. And let's repeat it with an even thinner lens or shallower lens. Now the focal point's here. What this is telling us is that the bigger the curvature on the lens, the stronger the lens is. It brings that focal point in much sooner. With a shallower lens, the focal point moves away further. This is a measure of focal length. Focal length is taken from the center of the lens. So if we were to put a mark here, roughly, so that's the center of the lens, and we'd measure from the center to the focal point. So again, let's look on the board at that. So we'd measure from this point here to the focal point. That's then the focal length. Different lenses have different focal lengths. If we put this one back on, we would measure from the center to there. The focal length is different. And again, for our lens that has the wider curve on it, the focal length will be from the center to this point. So that's how we measure focal length. It's really easy. Now let's look to see what happens when we use a concave lens. Now we can see here, I don't know how good the camera is, so I'll trace the lines. We can see here that the lines have diverged. They've diverged out. We can also just about make out another focal point here. That's why this is called a diverging lens. And the same applies. If we increase the depth of the curve, we change the focal length. For this one, we measure the focal length from the center of the lens to the focal point, which is here. Now we can see that the ray, the central ray, this one here, is still going straight. That's because at the center of the lens there's no curvature. If we get an exam question like this on the board, showing a concave lens with the principal focus, and it asks you to draw the rays going through the lens, it's really easy. All we have to do is draw the lines from the principal focus to where they hit the edge of the lens. Let's do that now. Obviously, you'd use a ruler in the exam, not doing what I do. We show them as dotted lines because that's a virtual image. We'll talk about that later, but it's a virtual image, it's not real. And from those, we can draw our solid lines out. We can also draw more rays in as well. That's showing our diverging lens and how the rays diverge across it. So we can say that these disperse the light. Let's have a look now for a concave lens. For a concave lens, I've just done it the other way around now, just to show that all lenses have a focal point each side. So this lens has a focal point here. It will also have a focal point here. So it just depends which way the light is going to enter it. Now that's our ray going straight through the center. Now we're going to draw on the real rays. We just want to show the rays converging to the focal point. And that's what we're going to show here. We can also draw arrows on just to show the direction of light. To measure the focal length on this lens, we'd measure to the center of the lens, and then with a ruler, we'd measure to the focal point. Now the first thing to remember about virtual images and real images is that a real image can be projected onto a screen. So a real image is something that we can actually see, like a projector would be projecting a real image. A virtual image, on the other hand, would be something like a mirror. We look at ourselves in the mirror, but it's not a real image, is it? It's virtual. Now, convex lenses give real images. Concave lenses give virtual images. If you can just separate that in your brain, then you'll be all right in the exam. But we will have a look in a bit more detail on the board. Another way to think of a virtual image is that it's a reflection. So that's the easiest way. We look in a mirror, but light can't pass through it. So it's a reflection of light. That's a virtual image. Now the important thing to remember when we're talking about convex and concave lenses, when we look at a convex lens and we think about the image it's going to produce, it will be real, it will be inverted, and it will be smaller. We'll look at why it's going to be inverted in a moment. If we take this little saxophone as an example, that's our object. So let's trace the rays, the light rays coming through it. Okay, so remember light is hitting this all the way here, but the light can only get through at the top and the bottom. So the light's going to come through here, straight, it's going to hit the lens, and then it's going to converge down. We take the bottom, we've got some light here, converging, well, about there, and another ray here. Now because the light's kind of swapped it round, hasn't it? The bottom is now the top is now the bottom. That means that it would look like that. It would be inverted, it would be smaller, and it would be a real image. This one, I haven't used a ruler, so it's not quite smaller, but you get the idea. Now let's have a look with a concave lens. Now again, we've got light coming into it all the way along. It's going to get through here. It's going to diverge and spread out. The same here, the light's going to come through, diverge and spread out. What we need to do now is trace those diverged lines back to show where the focal point is for the virtual image. That is our focal point. The reflected image would be shown there, and we can see that it's upright, it's virtual, and it's smaller than the real image. So let's summarize some of that. This is our convex lens. The wider it is in the center, the stronger its magnifying power will be. This one is weaker than this one. We measure the focal point from the center of the lens to where the light rays converge. This one will have the light rays converging much closer, whereas this one would have the focal point further away. Convex lenses produce real images, but they're inverted, that means they're upside down, and they're smaller. A real life example of that's our eyes. Actually, everything we see comes into our eyes because they're convex, and in the retina, the image is flipped round. But our brain translates that and flips it back for us, which is pretty handy. Concave lenses. Now, these produce virtual images. If the light rays come from this direction, the focal point will be here. the rays will diverge out and we trace back to the focal point. The focal length is from the centre to the focal point. If we increase the curvature, we'll increase the strength of the lens. And just remember, these produce virtual images. They're the right way round, but they are just reflections and they are also smaller. So I think that's everything to do with lenses. I really hope that's helped to simplify it, because sometimes in the book it can seem really confusing. If it did help, please like and subscribe and keep an eye out for all of the other videos that are coming up soon.